Hi everyone, welcome to my video. Today I'm going to show you how to configure this very interesting piece of hardware, the RTL-SDR software-defined radio, together with the Raspberry Pi board. We will be listening to FM radio from the broadcast radio band with Linux and these two pieces of hardware. But before we start, let me remind you, you can subscribe to my channel and press the bell button to get notifications about all the videos I'll be publishing. Now, let's start. Okay, let's start by having a look at the bill of materials for this experiment. I'll be using a Raspberry Pi 4 with 4 GB of RAM, a power supply, the standard for this board, an RTL-SDR dongle with a small pigtail coax cable and a VHF antenna from my handheld radio. I'll be also using a jack 3.5mm stereo audio cable, a micro SD card from Kingston with 8 GB or more. I'll be using a 16 GB version, a micro HDMI to HDMI cable for the video, so you can see all my experiments inside the operating system, and finally an USB keyboard and mouse to control my board. So before we start, let me show you a little bit about RTL-SDR. I will be visiting the website for you. Here we are. Unfortunately, the first thing we see is the sad news about a Arecibo radio telescope that just collapsed a few days ago. So long for this great radio telescope that had a huge impact in our radio astronomy projects worldwide. It was a huge one, okay? So, talking a little bit about RTL-SDR, let me show you the About page. Okay, so RTL-SDR is a software-defined radio project with a very special piece of hardware, very cheap one that became very popular. Since the beginning of software-defined radio, early in the 70s, people involved already knew what they wanted for this kind of equipment, but only in the 80s they start to get more serious about the concept, and in the 90s appeared the first projects using this software-defined radio technology. So the idea was to receive those radio signals and convert them from analog to digital using special integrated circuits, and use software for the demodulation process, and do exactly the opposite: modulate with the computer software and use special integrated circuits to inject these signals into the transmitter. This dongle RTL-SDR is special because it is very cheap and very powerful. It uses two integrated circuits, the R820T for tuning those signals and converting them to intermediate frequency, and then the R2832 that converts those signals to digital, samples the signals and sends them to the computer through the USB port. And there's where the Linux enters, because we have lots of nice libraries and softwares available for Linux to take care of these signals and make the rest of the magic, demodulating those signals. And that gives us the ability to make lots of nice and interesting experiments using this dongle. As you can see here below, we have lots of different types of radio signals or radio services we can access using this software-defined radio technology. For example, in this list below, you can see that we can track aircraft positions using the ADS-B decoding. I will make another video dedicated to air traffic monitoring. Also, for example, the PMR, DMR, D-Star digital radio, amateur radio VHF, for example, or UHF also. receive GPS signals and decode them. For example, decode NOAA weather satellite images using the specific frequencies and software. Listen to FM radio, the one I will show you today in this video, and many other technologies that are available today. So if you browse around the web page, you will see you have lots of tutorials that you can use to learn other things more in detail. You can keep track of other projects that are shown in this web page using this RTL-SDR dongle, and also keep track on new software that is released to different technologies, or even buy some hardware for your own experiments. Moving on, let's take care of the Raspberry Pi. We need to install the correct operating system. I'll be using today the Raspberry Pi OS 32 bits in a micro SD card. Don't forget to insert the card in your SD card reader, and after you do that, you are able to select the correct card you want to install the system to. Okay, so press right, confirm. In my case, let me put the password I need so I can give permissions to the writing process, and let's wait a little bit until the writing process is finished so we can proceed. I have fast forwarded this part. We are just waiting a little bit until it verifies so you can see the complete process. And now let's press continue and take care of the hardware. So now I will show you what we need to do in order to have access to the required hardware. Here we have the Raspberry Pi 4 board with all its connections. You see the dongle for the USB keyboard. Now let's install the micro SD card. We are done with that. We will also need the USB dongle, this one. You can reach this dongle in many online web stores in your country, or even directly from China. Search the best option in your case. You see the gold antenna connection I will use to connect to this small whip VHF UHF antenna. This is an antenna I use in my handheld radio. I will use it here, connecting the antenna directly to my dongle with this small MCX connector. And for the antenna, I'm okay now because it's enough to receive the required signals in this experiment. Of course, I will not have a huge radio range, but enough. So I have taken care of the video. Now I'm connecting the audio. So I can have access to the audio. This is required because the Linux drivers don't allow me to get audio from HDMI. And now I'm connecting the power. Okay, you see that the board is already powered on. Antenna, let me put it aside. And as you can see, I have already activity on the board. It is booting, so let's wait until the boot process is ready so we can start using the operating system. So this is a fresh, clean Raspberry Pi OS. I am taking care of the initial configurations about keyboard, language, time zone, etc. Please choose the best options in your case. I will set up a new password for my operating system, and then let me choose the Wi-Fi network I'll be using in this experiment. I will set up the Wi-Fi connection, putting also a password, and let's proceed with this fine-tuning. Okay, after we finish the install process, we will start dealing with some upgrades and installing the required software. I will open a terminal window so I can start taking care of that process. The Raspberry Pi is a very nice piece of hardware for this kind of experiments because it is also a cheap hardware, lightweight, with sufficient power in its CPU to handle these kind of tests. So I am pinging Google, checking my internet connection. I'm entering the root account and making the download of the update lists. And after that I will proceed with an overall upgrade to my operating system before I install the software we need. So this process can be quite long if your internet connection is not fast enough. So I am fast forwarding this process also for the video so you can see it as shortest as possible. After that, the software we will be installing is the GQ-RX. It's a general receiving software for software-defined radios, like the RTL-SDR we will be using here. But of course, you have other softwares available, like SDR Angel, that allows you to receive and also transmit if you have the correct radio license to transmit. Okay, it is now installing GQ-RX. This software is somehow big because it has to install lots of libraries and other dependencies required for the software to run properly. So the process has already finished, and now I will take care of the audio on this Raspberry Pi board. So getting here into the audio preferences, please select headphones so you can have access to the audio through the jack connector. I will reboot my board, and when it comes back I will have that audio routing correctly defined so I can capture the audio and you can listen to these signals. You will be noticing that the audio connection in this board is not very good. It has a very high or loud noise. So let's press run here and enter the name of the application, GQ-RX. Wait a little bit until the application appears, and here we are. As you can see, we have lots of settings we can configure. Let's just press start and see signals already being received. The waterfall below in blue and yellow. So this is the type of colors you can see between no signal and a radio signal being received. I am putting some more gain in my signals, and you already see that I'm receiving a radio signal. I'm tuning 100 MHz, 294 kHz and 500 Hz. So this is a local FM station here in Portugal. Let's go down, tuning other stations with strong signals. Some very well-known bands being received here. The funny thing is that you can see the spectrum of the radio signal. You can control all the specifications about the signal you are receiving. If you are interested in telecommunications, you can do lots of fun stuff with this. Another curiosity is that this application is available also for Mac OS and Windows if you prefer to use those systems, and has a cross-platform application. You can go from one to other. Another station with a very well-known music. to stop and listen a little bit when we find the music we like. Okay, moving on. Let's see what else we have here in the FM band, the broadcast FM, going down a little bit more. We keep finding new radio stations. Fortunately, we still have lots of FM broadcast radios here in Portugal. I know that across the globe, FM is still being used a lot, and people listen to music, especially when they drive their car, in the morning, in the afternoon, even at work. Here you can listen to a Portuguese music from a young famous singer. Here in the view menu you have lots of settings, including RDS. When available, you can check the RDS information being sent by the radio station. We have also hardware settings you can adjust, like the automatic gain control of the receiver, for example the zoom of the graphical waterfall, and some input configurations regarding the audio and UDP connections to the software. Let's browse around a little bit more to check if we can listen to another radio. Or now I'm going up a little bit to see the rest of the band, and as you can see, using this small antenna, indoor antenna, I'm using. Okay, so I have opened the audio options, so you can see that we have access to some configurations. We can connect through UDP to get access to the application and get this audio also for external usage. So another radio, I'm almost finishing because the band ends at 108 megahertz. But even though it's a very nice ride to get across the band and check what radios we have available and fine-tune the radio you like the most and listening to it with this Raspberry Pi and RTL-SDR dongle. So Linux is a very dynamic tool. It allows us to have this RTL-SDR dongle connected with the details I'm showing you in this window. Of course, the operating system has lots of other features that make this available: networking resources, all kind of libraries and drivers that connect to this hardware, so that we can make these kind of experiments and go even further exploring these technologies. The video I prepared today for you was meant to take you out of the box and see Linux differently, instead of using it specifically for computing technologies, to take Linux for other type of purpose, in this case using it for radio. I hope you have enjoyed this video as much as I did preparing it for you. So please comment below for any questions or suggestions. And don't forget to subscribe to my channel and press the bell button to get notifications about all the videos I'll be publishing. So take care guys, thank you for watching, see you on my next video.